Day 166 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem, but y'all already knew we would be here. Why? Because we're here every day doing a LeetCode problem while we're on our journey to become the best Swift programmers we could be in the entire world, y'all. We're trying to be the best of the best, and we have to do what it takes in order to achieve that goal. And one of the things that that's going to take is discipline and consistency to keep going and to be here every day doing another LeetCode problem and learning something new every day, y'all. We're all here to learn. We're all here because we want to be the best programmers. So welcome to the channel if this is your first time. And if not, welcome back, y'all. You already know how we do. We're doing LeetCode every day, and we're going to keep pushing through until we achieve all of our goals, y'all. So before we get started today, don't forget, bring your mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we could do our part in helping the Swift community to grow by pushing this content out to as many people as we can, y'all. One way we could push this content out is to run up this engagement, y'all. So y'all support is appreciated for that and helping me to run up this engagement and do what we need to do in order to get this content out and help the Swift community to grow. So, with all that being said, let's get started. And today we have question number 653, 2 sum 4. Input is a BST. BST stands for binary search tree, just in case you did not know. We made it all the way to 2 sum 4. We've been doing 2 sums since day number 1. Day number 1 started with a 2 sum, and now 166 days later, we're on 2 sum 4, y'all. So the difficulty level is easy. So you already know we're going to keep the solution as simple and easy to understand as well, because we're all here to learn. And if you don't understand the solution by the end of this video, then you probably didn't learn anything, and that is not what we want. So let's see what the question says. It says, given the root of a binary search tree and an integer k, return true if there exist 2 elements in a binary search tree such that their sum is equal to k, or false otherwise. So let's break that down so we can see what they mean. So we have this binary search tree right here, and we want to see how we want to see which 2 nodes we could find that will add up, their sum will add up to k. So let's look at example 1. Example 1, we have the root. It's an array, or it's an array of integers, or a binary search tree, and k equals 9. The output is true. So first let's go work. Let's look at how this array of integers corresponds to this binary search tree, right? So first we have right here the head, or the root, right? 5. So 5 we have right here, right? Then we have, you see 5 has 2 nodes, children nodes connected to it, right? So it goes 5 leads to 3 on the left and 6 on the right. That's where this 3 and 6 comes from after the 5, right? So it goes 5, then we start from the left, we put the 3 right here, we got the 5, then we come down to the left, we put the 3 right here, then we come down to the right, we put the 6 right here, right? Boom. Then we got to do the 3. So we're going to always start from the left, or with the binary search tree. So we're going to do the 3s next, right? So then that's where this 2 comes from right here, and this 4 comes from right here, right? Because we had to get the leaf nodes from the 3. Then the 6, we come right here, is nothing. That's why we put the null right here. Boom. And then we come to the right of the 6, and it's a 7. So the left of the 6 is a null, right of the 6 is a 7, and that's where the null and the 7 comes from. So I hope that made sense to y'all. And now that we understand that, let's go through how the problem actually works. So we have k equals 9. We want to find if there exist 2 elements in a binary search tree such that their sum is equal to k, or false otherwise. So in this example, k equals 9, right? So we want to find 2 elements that add together to equal 9, and they're all lit up for us with different colors. So we could see 4 and 5, that equals 9. 3 and 6, that equals 9. 2 and 7, that equals 9. So we have 3 different pairs of numbers or integers we could add together to equal 9. That's why the output is true, because we only really need 1, but we have 3 in this example, so that's why the output is true. So let's look at example 2, where the input root is the array of integers 5, 3, 6, 2, 4, null 7, or the binary search tree. This time k equals 28. The output is false because there are no 2 integers in this whole binary search tree that we could add together to get 28. None of these numbers are over 10 to start with, so it's no way we're going to get all the way up to 28 just by adding 2 numbers together. That's why the output is false. We could do these, 3 plus 6, that'd be 9. We could do the 2 largest numbers, 6 and 7. We could do 6 plus 7, that'd give us 13. Still nowhere close to 28, y'all. So that's why the output is false, because it's impossible to add 2 numbers together in this binary search tree to give us 28. So now that we understand the question, let's get into the fun part, the actual code, the part that keeps us all motivated in the morning to keep going and keep learning more LeetCode. Let's get into it. And with this problem, the first thing we are going to do is we are going to create a helper function, right? So it's going to be helper, boom, open up the parentheses, do the underscore, then we're going to say root, colon, tree node, boom. Then we're going to put the question mark after tree node. We're going to say comma. Then we're going to do underscore r, colon, in out. And what this in out does, it allows us to, mutate or change the r variable inside the function and outside the function, right? So it will mutate the value of r inside the function, and that value will also reflect outside of the function. So we're going to say in out, we're going to say an array of integers. Come over here, open up the brackets. We're going to say if root is equal to nil, meaning there's nothing right there. In this case, it says null, but nil, when we're working with Swift, we say nil. We're just going to return. We're just going to return. That's all we're going to do. Then we're going to come down here and we're going to say, use a little bit of recursion. We're going to say helper, open up the parentheses, root, exclamation point, dot left, comma, and r. So when we have to use this and sign before the variable or the parameter when we're using in out, right? So when we're using in out, we have to use the and sign to let us know that that's what we're working with, right? So then we're going to come underneath that and we're going to say r dot append, open up the parentheses, we're going to say root, exclamation point, dot val. So that's going to append the value of the root to the R array that we created. Then we're going to come down here, use some more recursion for the right side, and we're going to say helper, we should get rid of this T up here. We're going to say helper, open up the parentheses, root, exclamation point, right, comma, and R. Boom. So that's it for our helper function. So now we're going to come up here and we're going to create this function, the find target function, right? We're going to say var r, that's going to be equal to an array of integers. Come outside that, put the parentheses. Then we're going to come down here. We're going to call the helper function that we just created. We're going to say helper, open up the parentheses, and we're going to pass in the root, comma, and r, right? Because remember, we're working with the in out. So then we're going to come underneath that, and we are going to say for I in 0 up to r dot count, boom. So that's going to iterate through a list of nodes first. Then we're going to do the same thing. We're going to say for j in I plus 1 up to r dot count, because remember, y'all, we trying to add 2 nodes together, and in order to do that, we're going to have to loop through I. We're going to have to do for an I loop, then we're going to have to do j, which will be I plus 1, right? So if this is I, this would be j. If 5 is I, then 3 would be j, right? And we're just going to iterate through like that through the whole array or the whole tree, the whole binary search tree, until we find two numbers that equal k, and we're gonna code that by saying if r, open up the square brackets of I, boom, is equal to two equal signs. Remember, this gives us no, excuse me, not equal to, because we want plus, y'all, because we want to add them together. So I'm moving too fast. Sorry. We're gonna say if r of I plus r j of j. Now we use the two equal signs. Is equal to k. Remember, this is going to return a boolean. It's either going to be true or false. If it does equal to k, it's true. If it doesn't equal to k, it's false. So if it does equal to k, we're going to say return true. Else we're going to come outside the for loop and we're just going to say return false, y'all. And that should be all she wrote. Let's run it. Make sure it runs. Make sure it's doing what it's supposed to do. Let's see, and there it is, y'all. It's accepted, so let's submit it. Let's see. Let's submit it. Make sure it stays accepted, y'all. Let's see. And there it is, y'all. 51 milliseconds beats 91.30% of users with Swift, y'all. Not too bad at all. We got to practice a little bit of recursion. You know, I feel like you can never do too much recursion. There's always something more you could learn when it comes to recursion, especially for me at my level and where I'm at on my LeetCode journey. I'm still trying to understand this recursion stuff. So I feel like this was a good problem. Got some recursion practice, which is always good, y'all. And I hope y'all learned something as well. Get one more look at the code, y'all. And I hope to see y'all tomorrow for another day, another LeetCode problem, y'all. See y'all then.